Hello and welcome to the third lecture for CompTIA Security Plus 601 exam. Let's get started. To prevent these attacks, several measures can be implemented such as anti-CSRF tokens. Include a unique secret token in each form or request that a web application generates. This token must be validated by the server upon receiving a request to ensure it originated from the legitimate website. Same site cookies. Using the same site attribute for cookies to control how they are sent by cross site requests. It helps to mitigate CSRF by preventing cookies from being sent along with requests initiated from other sites. Refer and origin header verification. Check the referrer or origin headers in incoming requests to ensure they come from trusted sources. Cross site request forgery or CSRF. CSRF is a type of security vulnerability in which an attacker tricks a user into performing actions on a web application in which they are authenticated without their knowledge or intent. This attack exploits the trust that a web application has in the user's browser, allowing the attacker to send unauthorized commands or requests to the application on behalf of the user. CSRF can result in unauthorized actions such as changing account details, transferring files, or altering user data. Server-side request forgery or SSRF. It is a type of security vulnerability that occurs when an attacker can trick a server into making unintended requests to internal or external resources. This exploit can allow an attacker to gain access to internal systems, retrieve sensitive data, or perform other malicious activities by leveraging the system privileged access. First, the attacker identifies an application feature that accepts URL of some sort of input for making network requests such as image fetcher, URL preview, etc. Then, the attacker crafts a request with a manipulated URL pointing to an internal service or sensitive endpoint that the server can access but is not intended to be accessible to users. After that, the application, trusting the user input, makes a request to the specified URL. Finally, the attacker can exploit this behavior to perform attacks such as accessing internal APIs, reading local files, interacting with cloud metadata services, and more. SSRF can be prevented by using input validation, whitelisting and blacklisting, IP filtering, separation of servers that can handle requests from the other internal services, and using a proxy. Driver manipulation. Driver manipulation is a malicious technique where attackers exploit vulnerabilities in device drivers, which are software components that allow the operating system to communicate with the hardware devices. These drivers operate with high-level system privileges, making them attractive targets for attackers seeking to gain unauthorized access or control over a system. By manipulating drivers, cybercriminals can execute arbitrary code, escalate privileges, and bypass security mechanisms. This can lead to severe consequences such as system crashes, data theft, or installation of persistent malware. Protecting against driver manipulation involves regularly updating drivers from trusted sources, implementing strong access control, and employing advanced security solutions like kernel-level protection and endpoint detection response or EDR systems to monitor and block malicious driver activities. Shimming. Shimming involves using a small layer of code known as a shim between the application and the underlying system functions it relies on in order to alter the behavior of a software application or operating system without modifying its original code. For example, it is used when running a Windows 7 application on the Windows 11 OS. Attackers use shimming to inject malicious code into a system, bypass security checks, or manipulate software behavior for their advantage. For example, a shim could be used to capture sensitive information such as passwords or encryption keys before they are processed by the system. Additionally, shimming can be used to maintain persistence on a compromised system by ensuring that the malicious code is executed every time a particular application runs. Refactoring malware. Refactoring malware, also known as refactoring metamorphic malware, involves modifying its code to change its structure without altering its functionality. This is achieved through several advanced techniques that make each instance of the malware appear different from previous versions, further complicating detection and analysis efforts. This ability to evolve and evade detection poses a significant challenge for cybersecurity defenses. A multi-layered approach is required for the same. SSL stripping. SSL stripping is a type of man-in-the-middle attack that downgrades a secure HTTPS connection to an unencrypted HTTP connection. This allows attackers to intercept and manipulate the traffic between a user's browser and a website without the user's knowledge. The attacker can then steal sensitive information such as login credentials, personal data, and financial details. When the user attempts to access a secure HTTPS website, the attacker intercepts the request and responds with an HTTP version of the site. This prevents the user's browser from establishing a secure HTTPS connection. The attacker then forwards the request to the actual website using HTTPS, establishing a secure connection on behalf of the user, and relays the content back to the user over an unencrypted HTTP connection. To prevent SSL stripping, use HSTS and software or extensions that automatically rewrite requests to use HTTPS whenever possible. Race condition. A race condition is a type of software bug that occurs when the behavior of a system depends on the sequence or timing of an uncontrollable events, such as scheduling of multiple threads or processes. This can lead to unpredictable behavior, data corruption, or system crashes. Race conditions are particularly prevalent in multi-threaded or distributed systems where multiple operations are executed concurrently. For example, two threads trying to withdraw money from the same bank account simultaneously. Without synchronization, both threads might read the same balance before either of them updates it, leading to an overdraft. Memory vulnerability. Memory vulnerabilities are crucial security flaws that arise from improper handling of memory operations in software, leading to potential exploitation by attackers. These vulnerabilities often occur due to errors like buffer overflow or use after free bugs, where memory is accessed after it has been freed. Such vulnerabilities can be exploited to execute arbitrary code, escalate privileges, or cause DOS attacks. Common types of memory vulnerabilities include stack overflows, heap overflows, and integer overflows. Preventing these issues involve adopting secure coding practices such as input validation, bounds checking, and using memory-safe programming languages such as Python. Null pointer deference occurs when a program attempts to access or modify memory using a null pointer, which can cause a crash or allow attackers to execute malicious code by manipulating the null pointer. Integer overflow happens when an arithmetic operation generates a numeric value too large to be stored in the assigned data type, causing unexpected behavior that the attacker can exploit to manipulate programmed execution or gain unauthorized access. Modern systems incorporate various mitigations such as ASLR, DEP, and runtime checks to detect and prevent exploitations of memory vulnerabilities. Directory traversal. Directory traversal attacks, also known as path traversal attacks, are a type of web security vulnerability that allows attackers to access files or directories outside the web server's root directory. In a directory traversal attack, the attacker exploits insufficient input validation or lack of proper standardization in a web application to navigate to directories or files that they shouldn't have access to. For example, suppose a web application accepts user input to specify a file path for loading a resource. If the application does not properly validate or standardize the input, an attacker could manipulate the input to traverse directories and access sensitive files, such as configuration files, user database, or even executable scripts. These attacks can have serious consequences, including unauthorized access to sensitive information, data leakage, and in some cases, remote code execution. To mitigate directory traversal attacks, Developers should implement strict input validation and use secure file access methods that prevent users from accessing files outside the intended directory structure. Additionally, web application firewalls and regular security audits can help detect and prevent such attacks. Improper error handling. Improper error handling is a common security vulnerability that occurs when a system fails to adequately manage errors, leading to the exposure of sensitive information or unexpected system behavior. When errors are not handled correctly, attackers can exploit them to gain insights into the inner workings of a system or to launch more sophisticated attacks. A common example is when errors are not properly logged or monitored. Without adequate logging and monitoring mechanisms in place, system admins might miss important error messages indicating potential security incidents or anonymous behavior. It can also happen when an error can show too much information about the system. API attacks. API attacks refer to malicious activities aimed at exploiting vulnerabilities in APIs or application programming interfaces. APIs serve as bridges that allow different software systems to communicate and interact with each other. However, when APIs are not secured properly, they can become vulnerable to various types of attacks, including SQL injection, parameter manipulation, or man in the middle attacks. Rogue access point. A rogue access point refers to an unauthorized wireless access point or AP that has been installed on the network without the explicit authorization of the network admin. These rogue APs are typically deployed by individual or attackers seeking to gain unauthorized access to the network or to launch various types of attacks, including eavesdropping, data interception, or network intrusion. Rogue access points can pose significant security risks to organizations as they can create backdoors into the network, bypassing perimeter security controls and allowing attackers to compromise sensitive data or launch further attacks. Moreover, rogue APs can degrade network performance and reliability by causing interferences with legitimate wireless networks. Resource exhaustion. Resource exhaustion, also known as resource depletion attacks, occurs when an attacker consumes or depletes critical system resources, rendering the target system or service unavailable to legitimate users. These attacks aim to disrupt the normal operation of a system by overwhelming it with excessive volumes of requests or by exploiting the vulnerabilities to exhaust system resources such as CPU memory, network bandwidth, or disk space. For example, zip bomb and DCHP starvation. Wireless evil twin. Wireless evil twins are a type of rogue wireless access points that poses as a legitimate Wi-Fi network, tricking users into connecting to it instead of genuine networks. Unlike traditional rogue APs, which may have random or inconspicuous SSIDs, evil twin APs impersonate known and trust networks by using the same SSID, encryption type, and other network parameters. The term evil twin reflects the deceptive nature of these rogue APs, as they mimic the characteristics of a legitimate network to lure unsuspecting users into connecting with them. Once connected, attackers can intercept, monitor, or manipulate the network traffic of connected devices, potentially compromising sensitive information such as login credentials, financial data, or personal communications. Bluejacking and blue snuffing. Bluejacking is a relatively harmless form of cyber attack where an attacker sends unsolicited messages or business cards to Bluetooth enabled devices such as smartphones, tablets, or laptops within close proximity. The attacker exploits a vulnerability into the Bluetooth protocol that allows sending of messages or contact information to nearby devices without pairing or authorization. These messages often appear as pop up notifications on the victim's device containing text or images. The primary purpose of bluejacking is usually to annoy or prank the victim rather than to cause harm or steal information. Bluejacking does not involve accessing or compromising the victim's device. It simply takes advantage of the device's Bluetooth functionality to send messages. Blue snuffing is a more serious Bluetooth attack that involves unauthorized access to information stored on a Bluetooth enabled device, such as contacts, emails, text messages, or multimedia files. Unlike bluejacking, which only involves sending messages, blue snuffing exploits security vulnerabilities in the Bluetooth protocol to gain unauthorized access to the victim's device and extract sensitive information without the user's knowledge or consent. This type of attack typically requires the attacker to have specialized tools or software that can exploit the Bluetooth vulnerabilities. Blue snuffing attacks can pose significant privacy and security risks, as attackers can steal sensitive personal or corporate data from vulnerable devices. Wireless disassociation attacks. Wireless disassociation attacks, also known as deauthentication attacks, are a type of cyber attack targeting Wi-Fi networks. In a disassociation attack, an attacker sends forced deauthentication or dissociation frames to one or more devices connected to a Wi-Fi network. These frames are legitimate management frames used by Wi-Fi protocol to manage the association and disassociation of devices with access points. By flooding the target devices with these forged frames, the attacker can force them to disconnect from the network, effectively denying them access to network resource. Wireless or radio frequency jamming. Wireless jamming, also known as RF jamming, is the intentional disruption of wireless communication systems by transmitting interference signals on the same frequency bands used by the targeted devices. It's a form of cyber attack that aims to disrupt or prevent communication between wireless devices such as Wi-Fi networks, cellular networks, Bluetooth devices, or other radio frequency based technologies. NFC attacks or near field communication attacks. These attacks exploit the vulnerabilities in NFC technology, which enables short range wireless communication between devices, typically within a few centimeters. NFC is commonly used for contactless payments, data exchange, and device pairing. Despite its convenience and growing popularity, NFC can be susceptible to various types of attacks, such as eavesdropping, replay attacks, data corruption, DOS, and NFC spoofing. Randomizing cryptography. Randomizing cryptography involves the strategic use of randomness to enhance the security of cryptographic systems, ensuring the unpredictability and robustness necessary to protect sensitive information. This is achieved through incorporation of nonces, solves, and other random values in various cryptographic operations, which help prevent predictable patterns that could be exploited by attackers. A nonce is a random or pseudo value that is used only once within a specific context, typically in authentication process, encryption process, and digital signature. RFID attacks, also known as radio frequency identification attacks. These attacks target the vulnerabilities of RFID systems, which are widely used for tracking, identification, and access control in various industries. RFID attacks consist of tags containing data and readers which read and sometimes write data onto the tags via radio waves. Despite the utility, RFID systems can be susceptible to several types of attacks, such as eavesdropping, cloning, replay attacks, and data manipulation. A salt is a random value added to data before it is hashed, particularly in password hashing and other scenarios where preventing the generation of identical hash values for identical input data is essential. Salts and nonces can prevent replay attacks, ensure unique digital signatures, prevent hash collisions, enhance password security, and prevent pre-computed attacks. On-path attack. An on-path attack is a cybersecurity breach where an attacker intercepts and potentially alters the communication between two parties without their knowledge. This type of attack can compromise the confidentiality, integrity, and authenticity of the information being exchanged, making it a significant threat in various communication scenarios. It is often done using ARP spoofing. ARP poisoning, also known as ARP spoofing, is a type of cyber attack where an attacker sends falsified ARP messages over a local network. This is done to associate the attacker's MAC address with the IP address of a legitimate device on the other network, such as a gateway or another host, leading to interception, modification, or disruption of data traffic. A non-path browser attack, commonly referred to as a man in a browser attack, is a sophisticated type of cyber attack where the attacker intercepts and manipulates the communication between a user's web browser and the internet. Unlike traditional man in the middle attacks, which intercept communication between two endpoints, man in the browser attacks compromise the browser itself, gaining control over what the user sees and enters. This allows attackers to steal sensitive information, alter transactions, and inject malicious content. MAC flooding. MAC flooding is a network attack targeting switches in a LAN. The goal of this attack is to compromise the switch's operation and force it into a state where it behaves like a hub, broadcasting traffic to all ports. This enables the attacker to capture sensitive data being transmitted across the network. It occurs when the attacker sends a flood of packets with spoofed source MAC addresses to the switch, filling up the MAC address table. Since the table has a limited size, it eventually becomes full and switch can no longer store new MAC addresses. When that happens, the switch enters a fail-safe mode, acting like a hub. MAC clothing, also known as MAC spoofing, is a technique where an attacker changes the MAC address of the network interface to match the MAC address of another device on the network. This allows the attacker to bypass certain security measures such as MAC address filtering and impersonate the legitimate device, gaining unauthorized access or intercepting the network traffic. The attacker changes the MAC address of the network interface to match the MAC address of a legitimate device. By cloning the MAC address of a trusted device, the attacker can intercept traffic intended for that device. DNS poisoning. DNS poisoning, also known as DNS spoofing, is a type of a cyber attack where an attacker corrupts the DNS cache or database. This manipulation causes a DNS server to return an incorrect IP address, redirecting traffic to malicious sites or intercepting sensitive information. DNS translates human readable domain names into IP addresses that the computers use to identify each other on the network. The attacker interjects false DNS entries into the DNS server cache, so when a user tries to visit a legitimate website, the poisoned DNS server returns a false IP address, redirecting them to a malicious site controlled by the attacker. DNS hijacking, also known as DNS redirection, is a type of cyber attack where an attacker manipulates the DNS or the domain name system resolution to redirect users to malicious websites or intercept, alter, and monitor their internet traffic. Unlike DNS poisoning, which involves corrupting the DNS cache, DNS hijacking typically involves changing the DNS settings of a user's device, a router, or a DNS server itself. Domain hijacking. Domain hijacking is an attack where an attacker gains control over a domain name, allowing them to manipulate, redirect, or deny access to the domain. This type of attack can have severe consequences for businesses and individuals, including loss of control over their online presence, financial loss, and reputational damage. URL hijacking. URL hijacking, also known as typo squatting, is a type of cyber attack where an attacker registers domain names that are similar to legitimate websites. These domain names often contain common typographical errors made by users while entering the URL into their browser. The goal is to trick users into visiting the fraudulent websites, which can lead to various malicious outcomes such as phishing, malware distribution, or advertisement revenue generation. Sometimes it may even redirect to a competitor's website. Domain reputation. Domain reputation refers to the perceived trustworthiness and credibility of a domain name based on its history and behavior on the internet. It plays a crucial role in email deliverability, website security, and overall online presence. A domain with a good reputation is trusted by email servers, search engines, and users, while the domain with a poor reputation is often associated with spam, malwares, and other malicious activities. Application layer DOS attacks target the application layer of the OSI model, aiming to exhaust application resources or exploit vulnerabilities to disrupt service. A good example of the same would be the zip bomb. Operational technology or OT DOS targets the critical infrastructure and industrial control systems or ICS that are part of the operational technology environments. These attacks aim to disrupt the normal operation of an industrial process such as manufacturing, energy distribution, transportation system, and other essential services. Denial of service or DOS. DOS attacks are malicious attempts to disrupt the normal functioning of a targeted user, service, or network by overwhelming it with a flood of illegitimate traffic. The goal of a DOS attack is to render the target resource unavailable to its intended users, causing disruption, downtime, and potentially financial losses for the victimized organization by flooding traffic, exploiting vulnerabilities and protocol, and physical damages. A DOS may also occur due to mishaps, accidents, or mismanagement within the organization. Distributed denial of service or DDoS. A DDoS attack is a malicious attempt to disrupt the normal functioning of a targeted user, service, or network by flooding it with a large volume of traffic from multiple sources. These attacks overwhelm the target's resources, causing service degradation or complete unavailability for legitimate users. DDoS application amplification attacks are a type of DDoS attacks that exploit vulnerabilities in certain network protocols to amplify the volume of traffic sent to the targets, making the attack more potent. These attacks typically involve sending a small request to a vulnerable server or or service, which then generates a much larger response to the victim's IP address.